The intermediate value theorem is an existence theorem. It proves the existence of an intermediate value. It says if a function is continuous on a closed interval a to b, and k is any number between f of a and f of b. These are the y values for the endpoints. Therefore, k is a y value. Then there is at least one number c in the interval such that f of c equals k. What does that look like? Here's a continuous function. Let's say this is called f of x, and this is a, and this is b, beginning and end of our interval. Then go to the function. This y value would be f of a. Go to the function. This y value would be f of b. If I can draw from f of a to f of b without picking up my pencil because it's a continuous function, I know I have to hit every single y value in between. Let's just pick a random k. Here, some y value in between f of a and f of b. Well, if I go over to my function, here's a spot where it hits. Here's another. Here's another. I know it had to hit at least one time. In my picture, it hit 3 times. What if I connect straight from that end to that end? Still, I've hit that y value that's between one time. At least one time it will be hit. I can prove the existence of a value that's between those two y values is going to exist. A point on the function. Here's another way to think about it. If I were 3 feet tall at some point in my life, and now I'm 5 feet 5 inches tall, is it possible to say that at some point in my life I was 4 feet tall? Why? Well, here's a little visual. I'm 3 feet here, and here I'm 5 feet 5 inches. Growth is a continuous function. Growth is continuous. We cannot skip from 3 feet to 5 feet. It just is not possible. At some point in between, I don't know when. I'm not saying I have to know when. I'm just saying that it has to exist. There has to be some point at which I hit 4 feet. So since growth is continuous and 4 is between 3 and 5 or 5 feet 5 inches, IVT tells me, or by IVT, intermediate value theorem, I had to be 4 feet at some point in this growing in my life. Here's the typical problem that you're going to encounter. Use the intermediate value theorem to show that this function has a 0 on the interval 0 to 1. So remember the two things we have to show. F of x is continuous. Now we don't really have to show it, like prove it, we just have to state it. Now it's a polynomial, I know that those are continuous everywhere. So I specify that it's on that closed interval that they gave. Second thing I have to prove is that the k value I'm looking for is between the y value of the endpoints. Well, here's the endpoints, a and b, and 0 is the y value I'm proving. 0 means the function equals 0 at some point. So let's look at what those endpoints give me as y values. F of 0, plugging that in, 0 cubed plus 2 times 0 minus 1 makes -1. And f of 1, 1 cubed plus 2 times 1 minus 1 gives me 2. Whoops, I said -1, and I wrote -2. Is 0 between -1 and 2? It sure is, so I'm going to write that. 0 is between -1 and 2. So I stated that the function's continuous on the interval. I stated that the 0, what I'm looking for, is between those endpoint y values. Therefore, by IVT, f of x equals 0 for some x on 0 to 1. Let's look at another example. Verify that the intermediate value theorem, IVT, applies to the indicated interval and find the value of c guaranteed by the theorem. F of x equals x squared plus x over x minus 1 on the interval 5/2 to 4, f of c equals 6. So we're looking to verify that f of c will equal 6 somewhere on this interval. Now, the first thing I notice is we have a rational function, a denominator, and we never want the denominator to equal 0. There's undefined points there. Well, where does that happen? That happens at x equals 1. However, 1 is not on our interval. This goes from 2.5 to 4. 1 is not included on the interval. Therefore, I can say confidently, because I understand how rational functions work, that f of x is continuous on the interval that's given, 5/2 to 4. And that's an important first statement for the intermediate value theorem. Next, we're going to look at what happens when we plug in 5/2 into our function. We get 5 and 5/6. Then we're going to look at what happens when we plug the other end of our interval into our function. So f of 4 equals 6 and 2/3. So I notice that these values land on either side of 6. Therefore, I know the function must hit 6 somewhere along the way. So here's how we state that. Since f of x, since 5 and 5/6 is less than 6, which is less than 6 and 2/3. In other words, 6, the y value we are looking to prove exists, is between those two y values that we found by intermediate value theorem. Now, we already stated that the function is continuous, so we don't have to do that again. This is done. So by intermediate value theorem, f of c must equal 6 for some c on the interval 5/2 to 4. So we've proven that f of x will equal 6 at some x value on the interval. Now, the second part of the question, find the value of c where that happens. We're not always asked to do that, but since here we are, we will do that. So I'm going to set x squared plus x over x minus 1 equal to 6, right? F of x has to equal 6 somewhere. I can cross multiply to get x squared plus x equals 6x minus 6. I can set it equal to 0 since this looks like a quadratic. And then I can factor, it factors nicely. And I see that x equals 2 and x equals 3. However, it asks for the value of c guaranteed by the theorem on this interval. 2 is not on the interval, so c, our answer to the question, will equal 3. Again, why? It's because 2 is not included in the set of numbers going from 5/2 to 4.